We have an uncertain future. We take a finite number of resources, make something out of them, and ultimately, at the end of their life, throw them away. The wasteful approach we have applied to natural resources in construction is not compatible with the well-being of future generations. In a circular economy, resources are kept in use and their value retained. The concept stage establishes the basis for a project. Decisions made at this stage will have repercussions throughout and will impact the project's ability to work in a circular fashion. To establish a position of lowest impact, projects should consider if there is the opportunity to reuse or refurbish an existing building. This typically has a smaller impact than a new build. The smaller the circles represented here, the least impact it has. Design offers the biggest opportunity to deliver a circular economy approach. Decisions made at the design stage impact upon the value retained within a structure and materials life cycle. Projects need to design for reuse with durability in mind, making it easier to repair or upgrade, reuse, recycle, or recover at end of the life. Design principles for a circular economy include building in layers, designing out waste, designing for adaptability, designing for disassembly, deconstruction, and the selection of materials for circularity. The construction phase has the ability to either enhance or inhibit the delivery of the design brief. Decisions made about the method of construction, material choice, site management, and build quality impacts at future stages. Recycled materials should be used intelligently. High recycled content does not necessarily mean lower impact, and the product itself may not be recyclable. Materials should be reused or recycled after disassembly and deconstruction and should not contain hazardous substances. Good site management helps to retain the value of materials both on and off-site. The built environment should be considered an endowment for future generations. However, it can become a liability that has to be demolished at cost. Appropriate management and maintenance will help extend the use into the long term. Consideration must be given to the impact of any alteration on the ability of the structure to be reused, refurbished, or recycled at end of life. The opportunity to reuse or refurbish a structure should always be considered ahead of demolition. Conversion can often be a more cost-effective alternative and could lead to significant savings. At the end of an asset's life, steps can be taken to prevent waste generation. Materials in the existing asset could be of use. Pre-demolition surveys can help identify components or resources of use. Demolition can result in added benefit from the extraction of value items. Leasing or the pre-sale of resources by the owner may encourage careful extraction of resources to retain value. To achieve circularity, no phase can work in isolation. The sustainable management of natural resources will require industry to capitalize upon opportunities offered by other sectors. The cascade of resources between sectors will maximize the value and use of these materials. With value, products and materials are more likely to be retained in use. This may be multiple times for a variety of different purposes across numerous industry sectors. Adopting circular economy practices in the construction and built environment sectors in Wales would lead to a benefit of £1 billion annually.